Hi, this is Rajshekar, and I'm here to explain concepts of data mining using SAS Enterprise Miner. So for that, we need a data set, and my data set is a data set where we predict the grade of milk if it's high, low, or medium, using the factors such as pH value, temperature, taste, order, fat, turbidity, and color. And these are all the factors which decide what grade of milk it is. So let's import that to the SAS Enterprise Miner. For that, basically, you need to pull the there's something called sample, and that there is something called file import thing. And if you import that, there is something called the train section. There is something called import file. You can choose the path, browse the path, and select the file. I already did it because if I run it, it's going to take a lot of time. This SAS Enterprise Matter takes a lot of time to run. So that's why I'm showing how to do it, but I'm not doing it right now. And once you import the file, you have a chance to edit variables. So by default, all the variables will show the role will be like as input. But here we are predicting grade, so you have to change that to target. By default, the role shows as input, but you have to change your predictor value to targets to make this work. Okay, so I did that, and there is something called Stat Explorer here. When you drag and drop this and connect that, it basically gives you some of the insights of the file which you imported. More or less, the output will be like this. Let me run that and show you that for you. It's taking a lot of time. That's the reason I don't run all the data models, and I'll just show you how to do that. So more or less the output is like this. It gives you the variable birth and a lot of insights about the data set. What's the mean, standard deviation, if there are any missing values of the variables, and grade, how the grade is predicted, what's the data role of train, how the data looks in that, and many others. So this is not much. To get the insights of the data, you can just do the static flow thing. Here, if you go, this is a second model. I am using data decision tree in this one. How to I showed you how to import the file and how to do the Stat Explorer. And additional thing from that, and this is the decision tree node, and you can find that in the model. So if in the model you can clearly see there is something called decision tree. Pull it up and join the Stat Explorer to decision tree. That's all. That's that simple. How this works. And after that, you're gonna just run it. If you run that, more or less the output would be like this. It gives you the splits, all the splits, how the splits are made, and the fit statistics, and how the train sum of frequencies, misclassification rate, and stuff. The more important thing here is the output. If you see, it has target and outcome variables, and how much percent of outcome percentage, what is the outcome percentage, what is the target percentage, frequency count, and total percentage. And here you can see the false negatives, true negatives, false positives. By this you can understand how good the model is. Here it gives cumulative fit, leaf statistics, tree maps, and all. More or less that is it. That's it about the data decision tree. If you go to the neural networks, again, it's pretty simple. If you go to the model, there is an option. There is a model called a neural network. Drag it, join it to the file import, and just run the neural networks. More or less, the output would be like this. Again, it gives you the fit statistics and the output. Again, it gives you the the false negatives, true negatives, false positives, true positives, the target and outcome values, target percentage. Yeah, by this you can select how good your model is, and you can see the average, square error graph, cumulative lift curve, and stuff. So let's move to the third thing. I'm trying an ensemble model here. Here, the ensemble model is a combination of decision tree and regression model. You can find these modules, the decision tree modules in the model, and even the regression model node in the model tab. So you can see it here, and you can even find the ensemble model thing in the model tab. So basically, it's like you're connecting it with the file to the decision tree regression model, and you're connecting both the decision and regression model to the ensemble model, and you are comparing all these three. If decision tree is good, regression model is good, or ensemble model, which is a combination of decision tree and regression model are good. If you see this, you can clearly see that the selected model is an ensemble model because it has better better misclassification rate. Lesser misclassification rate and lesser average square error than many. So SAS Enterprise Manager selected ensemble model as the best model. Again, you can see the cumulative lift and fit statistics here. Let's move on to the next thing, next concept. How validation affects the accuracy. So here I am doing the data partition. You can find the data partition time in the sample. So when you import the file, I'm doing data partition. There are I did two different ways of data partition. In the first thing, I trained 40% of data, validation set is 30%, and test is 30. Whereas in the second thing, it's 60, 20, 20. I use the same model, neural network model, and I run the model comparisons. So uh, see, you can clearly see the thing. It selected the first model where the validation set is 30 and 30. Validation misclassification is very less for that model. Average squared error is also pretty less for that model. So what the insight here is that you have to give a reasonable validation set for the better models. And next part is how the k values affect our models. So k here in the first model I selected MBR models here. In that I selected the number of neighbors as 5 for the first and number of neighbors as 10 for the second, and I ran the model comparison. For the for the number of neighbors as 5, k value is 5. You can see the misclassification rate is less, and that even the SAS said that that is a better model. Training average square error is less, so lesser the number of neighbors, I think more accurate the result it gave in this data set. So let's go to the next thing, learning rate and back propagation. So in neural networks, if you go to the neural networks, there is something called optimization here. If you select the training technique as back propagation, there you can change the learning rate accordingly. So this way I change the learning rate. One model's learning rate is 50, another model learning rate is 0.1. You can see the significant difference in the learning rate. Let's see how the results are. So the output is more or less selected the second neural network where the new learning rate is 0.1, because misclassification is pretty similar to both of them, but average square error is much lesser to that of the second model. I mean first model. So lesser the learning rate, more better the neural network model is, because if the learning rate is high, there is a chance that you might miss the best fit of the best predictive model or the best weight set, which gives you a result. So these are the concepts I wanted to explain today, and thank you.